Welcome to the 18th lecture in the course of Industrial Engineering and Operations Research. Today we will discuss the topic of scheduling. This lecture will be given in two parts. So, part 1 is this lecture, and then after that I will discuss about part 2 also. Scheduling means that you have to make proper time sequence of the jobs, that in what manner the job should be done. So, there are many books in which scheduling is described, but you can have this book by Bufa and Sarin also. This can be a good reference material for scheduling topic. So, we will discuss job shop scheduling. What is a job shop? You know that suppose there is a workshop in which you make many different type of products. So, it is basically it is a process focused production system. Depending, you have say some milling machines there, some turning machine there, some broaching machine there, like that you have many machines and there are different type of jobs you do. Okay. Unlike flow type of production in which you do mass production and you keep producing only one item, here many jobs come. So, you may have that type of situation that you have only 5 machines, but you have got 50 jobs to do, then in what sequence you should be doing that. Or there may be situation, simple one, that you have only one machine, but there are 10 jobs waiting, in what way you have to do that. So, we will study the simple case, then naturally with that basis you can handle complicated cases, and of course, because if very complex situation is there, so nowadays people are doing scheduling also using software. So, we have to tell the basics to you. So, a job shop is a process focused production system. Production is to order, that means somebody has given an order, then you give production, and a large number of different products are produced, each in relatively small volume. So, here that is the characteristic of a job shop, that production is to order and a large number of different products are produced, each in relatively small volume. Examples of job shops include machine shops like workshop, then maybe computer center where different jobs are there and they have to be processed by in a sequence. Suppose there is a supercomputer also, but there are say 1000 jobs waiting to be done, then it also has some sequence. Printing centers and a paint shop. A production manager of a job shop uses the result of scheduling in several aspects of decision making. These results of scheduling are useful in decisions concerning order acceptance, due date specifications and product mix considerations. So, production manager will use these results. He may decide that whether to accept any new order or not, what is the due date and what type of jobs he has to make. The manager decides on a daily basis how many jobs and which jobs to release to the shop for processing. The criteria for machine utilization and customer service will be important. So, one can have many criteria. So, one is the customer satisfaction, other is the machine also should be properly utilized. These are the considerations. So, let us take one example of job shop scheduling. Suppose there is only single machine and industry produces several different products. We consider A, B, C and D product. However, only one product can be produced at a time. So, product is A, B, C, D and production time is given. A takes 7 days, but due date is 9. Okay. B is equal to 8, production time is 8, but it has to be done by 17th of that month. Okay. If things start from the beginning of the month. Then product C takes 4 days, but its due date is only 6th day, that day 6. And this is D, which takes only 2 days to process, but due date is 19. So, suppose the production manager has to decide on the scheduling of 4 products and the production times and due dates for which are shown in table. You have seen this table. Now, product A requires 7 days in manufacturing and is due to be delivered in 9 days. The manager has several alternatives for scheduling the production of these 4 products. Manager may produce product A first and then product B, followed by product C and finally product D. That means, we can do everything in the sequence given A, B, C, D like that, else product D can be produced first, next product B, then product A and finally product C. Many things can be done, sequencing can be different. So, in how many ways this can be done? So, there are 4 into 3 into 2 into 1 is equal to factorial 4 is equal to 24 distinct ways of scheduling the production of these 4 different products. How? Because first job can be any of the 4. Either we can choose A or we can choose B or we can choose C or we can choose D. Once you have chosen one way, with that one other for second position, second job in the sequence can be any of the remaining 3. So, 4 into 3, so distinct ways. Then if these 2 have been chosen, then the third job you have choice to choose any out of 2 and then the lastly you have one job left. So, therefore, total it will be 4 into 3 into 2 into 1 ways. That means 24 distinct ways. So, decision facing the production manager is which one of these possible 24 schedules should be chosen. Now, here it is only we have got 4 jobs. So, you see that there are factorial 4, that means 24 ways. Now, supposing you have factor 10 jobs to schedule, then it will be that is factorial 10. This will be say factorial 10, okay, 10 factorial 10 ways. So, you see that how big number this one, not you have to say 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So, you can see that this number can be huge. So, this way it has become like this, and now so this example illustrates the problem of scheduling on a single processor or a single machine scheduling. The analysis of a single processor illustrates many important problems that arise in more complex situations. Okay. So, now we will go to next one. Let us go to some definitions. Each job in the single processor scheduling model is described by 2 parameters. Pi is equal to processing time for job I. So, Pi is the processing time for job I and Di is due date for job I. You have seen that for product A, processing time is 7 and due date Di is 9. In some cases, Ri, the ready time or release time or arrival time of job I may be useful. In the models discussed further, all jobs are available for processing at time 0, hence Ri is equal to 0 for all jobs. Okay. So, in this case, we have Ri is equal to this one. So, therefore, in this case, we are not that means all the jobs are ready. So, therefore, we can have Ri equal to 0. The processing time Pi includes setup time for job I. If job I is defined as a lot for several identical pieces, then Pi will denote the time required to process the complete lot. Due date Di may be set by customer requirements or by internal planning considerations. So, now what other variables we use, those things are described here. Okay. So, we will discuss that this one. So Wi is equal to waiting time for job I, that is the amount of job time job I has to wait before the beginning of processing time. Ci is equal to completion time I, the time at which the processing of job Ji is completed, and Fi is equal to flow time of job I, the amount of time a job spends in the system. Actually Fi is equal to Ci minus IR minus Ri, however Ri is equal to 0, hence Fi is equal to Ci. Then we define lateness of job I, that means how much late that job is, that is amount of time by which the completion time of job I exceeds its due date. Mathematically Li is equal to Ci minus Di, because this is the completion date and Di is the due date. So Li can be either positive or negative. If it is Li is positive, then this thing is called tardiness. It is violation of due date, that is tardiness. And if it is Li is negative, that means completion date is less than the due date, then Li is negative and it is called earliness. It represents the completion of a job before its due date. So general jobs of scheduling rules. There can be many ways to schedule the jobs. One can follow the earliest due date first, that means priority is given to the job with the earliest due date, because due date is early, so that is why it has to be produced first. Say for example, in this case job C has due date of 6 and other jobs can be submitted after that. So therefore job C will be chosen for scheduling on machine A at time 0. Then another approach is that first in system first served, priority is given to the job that arrived in the shop, not on the machine first. And first come first served FCFS means priority is given to the processing of the job that arrived at the machine first. And then least slack first, priority is given to the processing of the job that has least slack. Slack is the difference between the due date and the work remaining on the job. So that means there is a less amount of slack, so you assign first. Then shortest processing time is also one approach, that priority is given to the job with the shortest processing time on the machine under consideration. Then another approach is that least work remaining, priority is given to the job with the least amount of total processing remaining to be done. And then longest processing time, jobs with longest processing time are produced first. So these are different type of methods. Now, so this one, the choice of which priority rule to choose depends in part on how each rule performs on different criteria. The priority rules try to minimize completion time because and maximize facility utilization, minimize number of jobs in the system and minimize job lateness. These are our objectives. That is why we have to make some priority rule. We have to minimize the completion time, we have to utilize our facilities properly, and we also have to minimize number of jobs in the system and minimize job lateness. These performance criteria incorporate the concept of flow time. It measures the time each job spends waiting plus time being processed. That means whenever it remains in the system, that time is called flow time. For example, if job C waits 5 days for job B to be processed and then takes 3 more days of operation time itself, then its flow time will be 5 plus 3 means 8 days. Now, their performance criteria, mathematically they can written as average completion time, that means sum of total flow times divided by number of jobs. Then utilization metric, that total job work processing time divided by sum of total flow time. Average number of jobs in the system, that is sum of total flow time divided by total job work time. So this is basically the reverse of utilization metric, average number of jobs in the system. Then average job lateness is total late days divided by number of jobs. So, performance criteria can be computing the lateness of a particular job involves assumption about the start time during the day and the timing of delivering a completed job. So, job lateness is defined as maximum 0 yesterday means yesterday's date plus flow time minus due date. So, this will tell you about job lateness. Equation A assumes that today is a work day, work has not yet begun today, and a job finished by the end of a day can be delivered to the customer that same day. So, that way it is this one. For example, suppose that today is day 10 or 10th of the some month, say 10th of May, and yesterday was day 9. So, job A is due tomorrow, that is day 11, and it has a flow time of 1 day, that means it remains 1 day in the system. Then the job would be considered to be completed on time, not late, because maximum 0 comma and then this is yesterday was 9th plus 1 day flow time. So, and then date is 11. Okay. So, that means you have maximum 0 minus 1. So, in fact, this job is early. So, lateness is 0. So, this is 0 days late, and job B is due on suppose 25 and has a flow time of 12 days. The lateness of job B would be maximum 0. Let us say previous date is 19 plus 12, 12 is the flow time minus 25 is due date, that is maximum 0 to 6. So, 6 days late. So, you can find out how many days something is late, and then let us tell about priority rules for dispatching, in what way the job should be given to machine. So, 4 different products are to be produced. The production time and due dates are shown in table. I am taking the same example, but again reproduce the table here. So, you are already seeing that this table is there. Okay. So, you are having this one. Okay. So, it is so we are having A job. Okay. This is B job. Okay. C job, D job, and this time is there. Okay. So, example, now 4 different, so it determine the sequence of, now what we do that here, determine the sequence of processing as per FCFS, SPT, EDD and LPT rule. The work begins on day 1. So, as per FCFC rule, the sequence is shown in table. This is job sequence, then production time in days, flow time, due date in days, and job lateness. So, what we do that job sequence is that job A. So, we will have job A, this job is there, and production time in days 7, flow time is 7, due date is 9, and if we give that this job we are doing first, because if first come first served. So, it is there is no lateness, because due date was 9, but I finished it at 7. Then job B, this is 8, production time in days 8. So, first job will take 7 days. So, therefore, 7 plus 8 means in 15 days it will be over, but due date is 17, no problem, this is 0. Okay. Then what happens that job C, this is production time 4. So, 15 plus 4 19, but due date was 13 only. So, job is late by 6 days, because due date was 13 only. And D means production time in days is 2, flow time is 21, due date in days is 19, and job lateness is basically 2, because due date is 19 and you finished in 21 days. So, if you sum all the production time in days, it is only 21 days, but flow time was 62, and job lateness also has been summed up, that is comes out to be 8. So, as per FCFS means first come first served rule, the sequence ABCD is shown in table, that is there. So, average completion time is equal to sum of total flow time and then number of jobs, that means 62 by 4 is equal to 15.5 days, and utilization metric is total job work time divided by sum of total flow time, that means this becomes 21 and this is divided by 62. Total processing time is only 21, but total flow time is 62. So therefore 21 by 62 in terms of the percentage, that means you multiply this number by 100 also, then you get 33.87 percentage. 33.87 percentage. Average number of jobs in the system is reverse of that sum of total flow time 62, total job work processing time is 21. So 62 by 21 is equal to 2.95 jobs, and average lateness is total late days divided by number of jobs, that means 8 by 4 is equal to 2 days. Now this is by one method. Suppose we follow the shortest processing time rule, then the sequence DCAB is shown in table. Average completion time is equal to sum of total flow time divided by number of jobs, and then it becomes 42 by 4 and this becomes is equal to 10.2 days. So sum of the total flow times, because total flow time is 42, by that way see we have arranged in this sequence that D job is done first because it takes only 2 days, then C takes 4 days, then A takes 7 days, then B takes 8 days. So in the order of their processing time we have arranged, and we do the same type of thing that we calculate the job lateness in the same way, that here D is equal to this one 19 minus 2, they have the no lateness because due date is 19, but in A 7 and 9 due date is 9, but it is finished in 13, flow time is 13. So naturally that it is late by 4, it is basically the flow production time, it is same. So this is actually late, and similarly that it becomes 21 and this is 17. So this is also late by 4 days. So like that it is there. So utilization metric will give total job processing time, which is 21, but the sum of total flow time this time is 42. So you see that this time this figure is coming 50%. Basically 21 by 42 is 0.5, but multiply by 100. Average number of jobs in the system, that sum of total flow time divided by total job work time. So that becomes 42 by 21 is equal to 2 jobs, and average job lateness is total late days divided by number of jobs, that is 8 by 4, that means 2 days. So as per if you do by EDD rule, that means earliest due date. So by that if we arrange, then the jobs will have to be done by ACBD, because A has to be given on 9th, C on 13th, B on 17th and D by on 19th. So in that sequence I have arranged, and then average completion time in that case it will be the sum of total flow time. We see the total flow time that comes out to be now 58, okay, because we are starting from here 7, 11, this and it comes out to be 58. Whereas production time in days comes out to be 721 as usual. This figure will be remaining same everywhere. So this is it will be this one 21, and then due date will be this one, job lateness will be 4, okay, because for B product production time is 8, flow time is 19, and but due date was 17, so 2 days it is late. Similarly job D, flow time was 21, that means on 21st of that month it was completed, but the due date was 19th of that month, so 2 days it is late. So now average completion time is 58, number of jobs is 4, so 58 by 4, that means 14.5 days, and utilization metric total job work time divided by sum of total flow time, that means 21 by 58 is equal to 36.21%, and average number of jobs in the system is equal to sum of total flow time divided by total job work time. That means 58 by 21 and is equal to 2.76 jobs. Average job lateness is total late days divided by number of jobs. So, 4 by 4 is equal to 1 day. So, we have done that type of this one, and we just see that. Now, go to the this one. Okay. Another rule, as per longest processing time, sequence become BACD, because B takes maximum time to process 8 days, A takes only 7 days, and C takes 4 days, and D takes 22 days. So, total time, naturally production time in days total is 21 only, but the flow time differs, because 8 first job was done finished in 8, then 8 plus 7 15, and 15 we finished, 15 plus 4 19, then 19 plus 2. So, this is 63, and due date is also given corresponding, and you see the job lateness. For example, for job B there is no lateness, but for this one there is a lateness. So, this is what that it is shown here, and job C takes 6 days, job D takes 2 days late. Okay. So, therefore, total late time is 14 days. Now, average completion time is equal to sum of total flow time divided by number of jobs. That means 63 by 4. So, this will become 15.75 days. That is average completion time. And utilization metric is total job work processing time divided by sum of total flow time. So, total job work or processing time is 21 and divided by 63, this becomes 33.33%. Then average number of jobs in the system is equal to sum of total flow times divided by total job work processing time. It will be basically the inverse of utilization metric. So, 63 by 21 here it comes, and this is equal to 3 jobs. Average job lateness is total late days divided by number of jobs. That means 14 by 4 is equal to 3.5 days. So, this table is actually the previous table, that is what has been indicated here. Then, so if we consider that the results of different priority rules, so it will go that I have considered many rules can be there, but I have considered 4 rules. One was first come first served rule, whichever job comes first in that sequence. So, whatever the sequence was given. Other was the shortest processing time, another was earliest due date time, and LP means longest processing time. It is written here, EDD means earliest due date, LPT means longest processing time. So, we see that average completion times for all these are 15.5, 10.2, 14.5, 15.75. We see the shortest processing time method has given me a least amount of average completion time. So, this is somewhat better, that you know that it has given completion time got minimized, but the utilization metric was also better. 50% time your shop is properly utilized. In other cases it is not that much, and the average number of jobs in the system by other methods they are more, but by shortest processing time there are only 2 jobs in the system, and average lateness was 2 in FC first come first served method, average job lateness was 2, and SPT average job lateness was 2. But in earliest due date, obviously I am giving more focus to due date, that means I do not want to miss due date. So, jobs which are due first, they are processed first. So, even though the completion time may be more, but it is lateness is reduced, lateness is only 1. So, if your criteria is that I cannot afford a lateness, otherwise my goodwill in the market will become very bad. So, in that case you have to reduce that, and LPT longest processing time, that means average lateness is equal to 3.5. So, based on it is computation, it is found that LPT is least effective, that latest processing time here it is not giving me very good result. SPT is superior in two matrices. Shortest processing time gives me better average completion time and utilization time, and EDD is superior in average rateness. So, it is superior in average rateness. So, that type of thing. So, shortest processing time is the preferable technique for minimizing job flow and minimizing the average number of jobs in the system. Its disadvantage is that long duration jobs may be continuously pushed back in priority in favor of short duration jobs. So, due date etc. may get disturbed. Earliest due date minimizes maximum tardiness, which may be necessary for jobs that have a very heavy penalty after a certain date. So, EDD works well when lateness is an issue. And first come first served does not score well on most criteria, but neither does it score particularly poorly. It has the advantage, however, of appearing fair to customers, which is important in service system. So, you see that mathematics is not everything. Sometimes there are other considerations also, like suppose customers are there, they may say that I came first, but why you have given them first. These type of issues are also there. So, you cannot tell that no, I want to maximize my utilization or something, rather you have to satisfy the customer. So, therefore, first come first can be this one. So, like that we can have any criteria, we can do mathematics, then after that we can make our own judgment also, and based on that we can do scheduling. So, let us stop at this stage, and then in the part 2 I will tell something more about the scheduling. Thank you very much. Thank you for your attention. Okay.